Welcome back to Shinobi Codes, and today we are here for the lecture number 2, and we'll be understanding Fibonacci series over here and many other important aspects of recursions. So let's get started. Okay, so let's first understand what Fibonacci series looks like. Basically the term number 1 is 0, term number 2 is 1, 3 is 1, 4 is 1, and 5th is 3. Okay, this is the series. So I gave you this assignment, this homework, that I want you guys to understand what is the pattern amongst these terms. So if you are pretty good at basic logical reasoning, so you will say, okay, so this is the series and the next term will be 5, because the sum of these two terms is this term, the sum of these two terms is this term, the sum of these two terms is this one term, and sum of these two terms is this term. Basically the sum of previous two numbers, we can say over here that sum of previous two terms is equals to next term. That's it. So the first part is done and the second part is setting up a functional relationship. So we can obviously write like function of n is equals to function of n minus 1 plus function of n minus 2. Here the inner part, this function will return the value of that term, and n will be the argument, and the argument over here is equals to the term, the which term it is. Okay, so here we just had a basic understanding of Fibonacci series. Now last lecture we understood what a recursive function looks like. So first let's see how we can apply recursion to solve this problem. So I will always suggest you, okay, for any recursion problem, for let me just write a little bigger. Okay, so for any problem involving recursion, I will tell you a very sort of a shortcut. Okay, so let's just divide this into two parts. Okay, I would like, this is my way to explain it to guys. So if it is a basic problem, and if it is a a problem which is difficult to understand, you can say, okay, it's a little bit medium-ish problem. So for basic problem, what you can always do is try to, maybe I'll change the color, try to find a functional relationship. Now it will be very easy for functional relationship. Directly you can find functional relationships in easy problems. Okay, so for easy problems you can easily find the functional relationships. Like I'll explain this. Okay, and let's go to the medium problems. So for medium problems, what I'll advise you is to use the approach which we use in the lecture number 1, which is to give the entire work to someone else. Like I would say, give a lot of work to the problem. Just think. Okay, again, this will be much more clearer when we'll be solving some good questions, but what I mean by this is like, always you should do is assume that a sub problem is giving me the answer at this stage. Okay, so divide the problem. So basically what I want to say over here is that divide the problem into sub problem and assume that sub problem is giving me answer, and then think that what all changes I have to make, what all additions I have to make to eventually get the answer, assuming that sub problem will return answer. Now this might be very vague for you guys, and this is like just the basic lecture of recursion, so let's just leave it. I just want just keep this in mind, so that when you are solving some good questions, you should just remember this. Okay, so we were at Fibonacci problem, and this is a very basic problem. In fact, the first problem I solved using recursion, even in my days, was this question called as Fibonacci problem. Fibonacci problem is a very standard problem because here the functional relationship is very clear, very clear, because the definition of Fibonacci series is basically the sum of previous two terms. So functional relationship is very easy to find in this problem. So I can say that, okay, so this problem can be solved via recursion because I can find a functional relationship. Now what is the next step? Okay, very interesting step. So let's do one thing. whatever we have done till now, let's try to code it. Okay, so we were trying to code whatever we understood till now. Okay, so let's just see what all we have done till now. Okay, so first let's just mention the main function, and let's just assume an integer n, and let's just take its value from n, and here n represents the term we want, the term we want, yeah, the value of the term we want. Okay, so again, I'll just create a function. Int will be the return type because I expect it to return me the value of the Fibonacci term at nth Fibonacci nth term. Okay, so I will just write Fibonacci, and it will take an integer n as an argument, and all I know right now is that I can establish a relationship, a functional relationship here. So I can just say that, okay, let's just assume that there's an answer. It will be of integer type, and Fibonacci of n minus 1 plus you can say Fibonacci of n minus 2. Yeah, and let's just return this answer. Okay, cool. So whatever I knew till now, I have done its code, but this code is completely wrong. Okay, now if anyone can think the reason why this code is completely wrong, I am giving you 2 minutes. Okay, till that time, pause this video and think. What I can do is I can just take some space over here, and let's analyze that what is the problem in this code. So first let's, like, okay, maybe I should tell, okay, what's the problem over here. So suppose I give you a for loop, okay, which has int I equals to 0, and this condition is missing, and I say I plus plus, and this goes on. Okay, so there is nothing stopping this for loop. Similarly, for while loop, it's very necessary that we mention a terminating condition over here, and this, this continues. This doesn't, the thing which stops these loops from going to infinity is just this condition over here, and this condition over here. Now, one of the most important things which one has to consider while writing a recursive program is to find this functional relationship. And second and probably the most important thing which we want is existence of something called as base case. So this is a standardized name I heard somewhere, and I just started using it. Base case is nothing, don't just confuse yourself with so many terms. All you need to understand is I need something to stop this function iteration again and again. Okay, so can you tell me how this function iteration is happening? A child will ask. All I will say to him is, okay, basically the children who don't understand recursion well is only because they don't understand how the function calling is happening. Okay, so before we get into base case in depth, I just want you guys to understand how the function calling is happening, and this is probably one of the most important things in this entire chapter. If you understood that how function calling is happening, function callings are happening in recursion, then you have partly mastered recursion. Okay, so I have, there's standardized two ways to understand this. One is the tree way. So the tree way is simple. Okay, I established some rules over here which you need to understand, which you need to memorize, or you can understand. What is this rule? Okay, we'll be understanding this using this tree method. Okay, the first rule I would say is, okay, let's just establish rule along the way. Okay, so suppose the integral value I've given is 5, because let's keep a small value so that computation is easy. So I will call here function Fibonacci of int n, basically n, sorry, n, and basically n is 5. So the first function call happening over here is fib of 5. This will lead Now from this calling, it will go over here. Now there's nothing over here. I want an answer, and again I see a Fibonacci function, and this is calling Fibonacci of 4. Now remember this and never forget this. This entire section to the right side of plus side will remain untouched till till you get till you get me an answer, till you get me an answer. Means till the time you don't get the answer from this Fibonacci of n minus 1, you cannot touch the right side. Okay, so first priority right now for the program is to evaluate Fibonacci of 4. Okay, so here Fibonacci of 4 will be called Fibonacci of 4. Okay, so this cleans up, this mess cleans up, and now computer is not focusing on this. It's only focusing on finding Fibonacci of 4. Okay, so Fibonacci of 4 comes up, and again a similar problem is faced. I want an answer for Fibonacci of 4. I want something to be returned to Fibonacci of 5 very quickly. But here this says, okay, first go and find Fibonacci of 3. Again, this entire section will be untouched, and I will go and evaluate Fibonacci of 3 first. First go and evaluate Fibonacci of 3. Okay. A Fibonacci of 3 will be called again. Fibonacci of 3 will say first go and evaluate Fibonacci of 2, and then I will think about returning an answer. Okay. Fibonacci of 2 is going. Now any logical person will say this will go endlessly till the time you don't return a value. You have to give some value, some prerequisite value, some base case, some like some values, so that this eventually stops at some point. So yeah, okay, now I know that Fibonacci of 1, the first term of Fibonacci is I guess 0, yeah, and Fibonacci of the second term is 1. I know this thing. So what I'll do is, in this text editor right here, I will add some certain base case. This is called as base case. Now what is a base case? Base case is that condition which stops the function calling infinitely. So I will say, okay, I will say if n is equal to 1, means basically you are trying to find Fibonacci of 1, then return the answer. I already know the answer. Return the answer. Its answer is 0. And I will say again, there's a condition. Here the base case will have two if terms. Mostly the base case is a if term. Okay, so if n equal to 2, again, now I will tell you why we need two terms over here. This is also very interesting, but for now let's say that, okay, return 1, because this is the answer we already know. Now you will ask me that why have you not written for 3, 4, 5? Because we also know these terms. These are easy to evaluate. I don't know the 100th term, but I know the third, fourth, and fifth term. Why have you written just two terms? Okay, let's understand this here. When I'll be calling, okay, so Fibonacci of 0 doesn't exist. So I want that Fibonacci of, basically, let's just create some space downwards. So I know that Fibonacci of 0 doesn't exist. 0th term doesn't exist in this series. So I want to avoid this. To avoid this, what will I do? And first of all, who will call Fibonacci of 0 for the first time? It is going to be Fibonacci of 2, because Fibonacci of 2 is equals to Fibonacci of 1 and Fibonacci of 0. So I want to assure it that this is included in base case, so that this is never ever seen around, because this doesn't exist. This is nothing. Similarly, I am also afraid for Fibonacci of -1. Why? Because this also doesn't exist, and when is the first time when we are going to see? It's going to be here. Fibonacci of 1 exists, but Fibonacci of -1 doesn't exist. So here also it will be this. So I want to assure that this is never, these two terms are forbidden in the series of Fibonacci. I don't want to see them. So I will say, okay, do one thing, just give them, just include them in the base value. Now if I establish a new functional relationship, a new type of function, maybe anything, and I say that it is, f of n is equals to sum of previous four terms. Okay, so it will be like this, 2 3 4, yeah. So it will be like this. So here how many base cases will be there? First of all, it depends on the conditionary. Like if it starts from 1, then we have to assure that 1 2 3 and 4 are included in base case. So base case is subjective to the problem. You need to understand what kind of base case this problem will have. Okay, so we have talked about base case. Base case is also done. Now I want you guys to understand the function calling, which I called the one of the most important things which people miss. Okay, so as I said that Fibonacci of 2 is included in base case, so it will return a value. I know the second term has value of 1 because I have included it in this, I have included it over here in the sublime text. So it will return a value. Let's just use some different color for returning a value. It will return a value of 1. Okay, now in the Fibonacci of 3, assume this as 3. Okay, here I have got a value and this value is 1. Now I can touch the right side of Fibonacci of 3 and this will go with this will order me go and call Fibonacci of 1. I will be like, okay, it's in the base case, so it will go and call Fibonacci of 1. N will be equal to 1. I just n will be equal to 1 and it will return the value of 0. So cool. So it returned a value of 0. So eventually I have an answer. The first answer I have evaluated is of Fibonacci of 3. Interesting. So Fibonacci of 3, I have Fibonacci of 3, its value is 0 plus 1, which is 1. So I will return this answer. So as soon as it will touch this bracket, again very interesting, as soon as it will touch this bracket, it is going to return to Fibonacci of 4. Where? At this position. Wait, this is getting all mixed up. Wait. Again. I've got the value of Fibonacci of 3. Now it will say I will go to my master. Who called me? My master called me. Who was my master? Fibonacci of 4. So Fibonacci of 4, here assume this is 4. Here I've got this answer. This answer is 1. 0 plus 1 1. And now I this right side is again into action, and I will call Fibonacci of 4 minus 2, which is Fibonacci of 2, which is again a base case, and this base case will return a value 1. So 1 plus 1 will give me answer 2. So answer is equals to 2, and I will be returning this answer. Again, the master of Fibonacci of 4 is Fibonacci of 5. So it will return just when it will touch this bracket. As soon as it will touch this bracket, it will return to its master. Its master was Fibonacci of 5. Fibonacci of 5 has this part evaluated, so now it has to evaluate the right side. The right side is Fibonacci of 4. Fibonacci of 4. Again, entire sorry, Fibonacci of 3. I'm very sorry for this mistake. Fibonacci of 3, and now again Fibonacci of 3 will be called just how this was done over here. So this is the tree approach. I will again just quickly draw this, how this shit happened. Wait, let me just delete this entire thing. So okay, quickly, I first called Fibonacci of 5, Fibonacci of 5 called Fibonacci of 4, Fibonacci of 4 called Fibonacci of 3, Fibonacci of 3 called Fibonacci of 2, which was a base case, and so I returned a value, and so it was free, and it again called Fibonacci of 1, and it returned a value, and we got a Fibonacci of 3. Fibonacci of 3 returned its value to Fibonacci of 4. Now Fibonacci of 4 called Fibonacci of 2. Fibonacci of 2 is a base case, so it will return a value. So Fibonacci of 3 is also evaluated. Now Fibonacci of 5, we are at Fibonacci of 5, and we have Fibonacci of 4, so it will call Fibonacci of 3. 3 will again call 2 and 1, and at their base case, the base case will hit, and it will return a value, and finally we'll get the value of Fibonacci of 5. This is the tree approach. I guess this is more than enough for understanding the function calling. Yeah, that's how function calling happens, and this is how I have finally done, and I have done the dry run for this thing called as Fibonacci. Will be around this topic called this program called factorial. So what's the assignment for you guys? So again, please think about this problem. Okay, find the functional relationship. The same thing. First, try to find first you should know what is a factorial, and factorial is equals to 1 into 2 into all the terms till n. So I want you guys to write a function which will print maybe return an integral value which will be the factorial of n, using recursion. Use base cases, use this analogy I gave to you, and try to implement it on an id, and cool. So that's it for today, guys. I hope you like the lecture. Please like, share and subscribe so that I can continue this work.